It is time to play the music. It is time to light the lights. It's time to meet speakers for the lightning talks tonight. Night. Oh, no. This is not the Muppet Show. This is the most exciting part of the program, namely the lightning talks. We have 8 magnificent speakers who will talk exactly 5 minutes about a subject of their choice. And it will be great, because when the 5 minutes is over, we'll greet them with the most amazing applause, whether they are finished or not. And our first lightning talk is about, well, AI coding assistants are commonly seen as helpful, but this is not necessarily the case. Please welcome Frans Reijnhoudt as he explains how to outsmart a maliciously compliant AI bot.
All right. Hello. I'm going to show you in 5 minutes how you can outsmart a maliciously compliant AI bot. And the weapon of choice to do that are unit tests. Who loves writing unit tests, by the way? All right. And who hates it? I get it. Unit tests are supposed to prevent regression. But what do we often see in practice? And how do you know you have written enough unit tests? And why aren't they always effective? So, question, what do you normally do with a task that is not fun? I make it into a game. So that's what I did here too. I suppose you have a specification for what a function should do. This, by the way, is the state of the retirement in the Netherlands right now. And if you look at these dots are all possible implementations of that function. Look at, for example, to this green one. You see, this is a perfect implementation. If the age is 67 or over, you're retired, otherwise you're not. But look at this orange one. It's almost correct. It's correct for most ages. It only fails when your age is exactly 67 years. And this orange function, this is less correct. It fails for, well, it passes for most of us, but it fails for the retired at least. And this function doesn't work for any age. And then I had a sneaky idea. Suppose you have a few unit tests. Can you write an implementation that passes all these unit tests, but is still failing the specification? Maybe that makes you think of someone that you know, someone that is really good at following instructions, but while clearly missing the goal. For example, I think of my teenage daughter, who's an expert in this, by the way, and some AI that I used recently. And that's how I turned the game into a dialogue, a collaboration between you and an AI bot. Well, collaboration may be more like a battle, because when the AI bot starts writing an implementation, it maliciously writes the most worst implementation it can think of, this one. And the only thing you can do is defend by writing a good unit test. And this unit test slashes a lot of implementations, including the bot's implementation. But the bot strikes again with another implementation, which is also wrong, but at least it satisfies your unit test. And the only counterattack that you have is write another unit test. There you go. And which invalidates the implementation of the bot, but is still not correct. And look, it immediately turns to this implementation, which is also not correct. And with the last remaining strength that you have, you write a unit test that also slashes this one. And with all these unit tests combined, you have forced the AI to write a correct implementation. Yes, victory, you won. The game is all about unit tests, so I named it unittestgame.com, of course. And it helps you write effective unit tests. The example that I showed you before is an example of a level that is based on test-driven development. There are also levels that are based on mutation testing. And all this ultimately leads to the big question, are you smart and effective enough to outsmart a maliciously compliant AI bot? You can test it yourself at unittestgame.com. Fun fact, I myself was 6 weeks into coding this game before I realized I hadn't written any single unit test myself. And here I am, 1,500 unit tests later, really, but at least the refactorings that I did were painless. So, in the end, I want to encourage you, let's beat AI together with unit tests. Thank you.
I tried this game and I can highly recommend it. It's fun. For our next speaker, well, some people say more is more, which sounds logical. But our next speaker, Leeuwis, will attempt us to convince us to the logic of less is more. Leeuwis, give him a big hand.
Thank you. So, have you ever started working at a new project and you were explained the business rules and it all sounded kind of easy, but then you opened up the project and you were just baffled by all the complexities in there and you thought, oh, let's get rid of it. Let's throw everything away and start over fresh. Well, let's meet Ryan. Ryan is one of the minimalists and he was really living the American dream. So he was having a 6-figure income, buying a new shiny car every couple of years, and he was having lots and lots of stuff to play with as well. But he was still feeling a void, and he was looking for something. And he took a very radical change. What he did is he packed up all of his belongings in a couple of boxes, and he put it in the center of his house. And during the next 3 weeks, he would only unpack what he really needed at that moment. And after this 3-week experiment, he could get rid of 80% of all his stuff. And this really helped him, giving a lot more space, but also more time, right? Less stuff to pick up, less stuff to clean, and also he was having less depth, actually. And this helped him to find his purpose, or his passion. And we learned that this morning as well, right? So we saw the inventor of curl, and I think he really found his passion. But we also learned that, well, sometimes you really need that instant gratification, right? But maybe it's not giving you where you want to be in the end. So how can we apply this to code? What can we get rid of in our code, right? So the easiest thing I would say to get rid of is the code you didn't write yourself. So have a thorough look at all your dependencies. So this is the Java example. And do you really need multiple mocking frameworks or multiple JSON libraries? Are you really using all your dependencies or not? Because dependencies, well, often they also contain vulnerabilities, right? So they become liabilities. So this is another Java example. And if you have one of these dependencies on the right on your class path, you're actually vulnerable to remote code execution. And you have exploit kits like Why's Serial, which make that quite easy to exploit, actually. The next thing you can have a look at is obviously remove your dead code, right? Because it's still in version control. So might you ever need it, you can just look it up. But are your endpoints all really used in production? So we actually had a look at it with our team. And we found some endpoints which hadn't been called in a year. And the whole team forgot about them, but they were never removed. And after removing all that stuff, it actually also became easier to do a big migration afterwards. So that was a big help. But often, of course, we get a lot of time to add new stuff to our products, right? Well, it's harder to go back and revisit and make stuff shorter or simpler. Well, I would say that it's really useful. So this is a completely different domain, right? Aerospace. I know nothing about rockets, but I would say that the third iteration of this rocket, it looks more simple to my untrained eye. Probably it's maybe even easier to reason about and hopefully even more reliable as well. So should we really throw everything away, all our enters, all our spaces, everything? Well, maybe not. So this is the fizz-buzz exercise. You print all the numbers, and if it's divisible by 3, you print fizz, and if it's divisible by 5, you print buzz. And this is the shortest Java example I could find at the top. Well, it's short, but is it really simple? Well, it takes me some moments to wrap my head around it, so maybe not. But what can we remove making things easier? Well, this is Marie Kondo. She's a decluttering influencer, basically. And she says, don't underestimate the noise of written information. And by eliminating excess visual information, you can actually make your space much more peaceful and comfortable. And I have an example of that as well from Java. So these are some of the exceptions from the Java lang library. And I would say that the stuff on the right actually still has all the meaning preserved while being shorter and indeed being a bit more peaceful, so easier to work with. But of course, naming things is one of the 2 hardest problems in computer science, right? So you have naming things, cache invalidation, and off by 1 errors, the 2 hardest problems in computer science. So that's also not an easy thing to do. So let's go back all the way to the beginning, right? I showed you a complex picture, and actually this picture is really huge. So I'm only standing here in front of only a portion of it. And it depicts our financial system. And there's a lot of complexity even at this level of detail. So how do we make sense of the world around us? Well, we often recognize a lot of patterns, right? We as humans are very good at recognizing patterns. So for example, if I go to the bathroom over here, right, and I want to wash my hands, interacting with the faucet is very easy for me because I understand the pattern which is being used. But to get the soap, I don't know if you've been there, that was like a different story. So it needed an explanation for me to get some soap on my hands. So in programming, you often have design patterns. So should you always use them? Well, I would say not. So this is the same fizz-buzz exercise, but now the enterprise edition, having all your strategies, the visitors, and all your patterns. And it's mind-blowing 3,500 lines of code to get the same thing printed, basically. So in conclusion, try to keep everything simple, but simple is not easy. It's actually very hard. Try to find your purpose and stick to it and get rid of all the excess. Thank you very much.
Well, you have heard it. Less is more. For our next speaker, you probably have noticed the interesting sculpture on the pedestal in the lobby. And I'm very happy to say that we have the artist here who is going to explain us about the algorithms behind this interesting object. Please give a hand to Jeffrey.
Thank you very much. As you can see, I've got my little paper here because I need to put a lot of information in 5 minutes, and this helps me to keep on track. The upcoming minutes, I'm going to talk about how I use a self-developed algorithm, this isn't it, to make works of art. And it starts really pitiful. I saw this wallpaper by Studio Job, and I thought, I'm a developer, I can do this better. That was a big mistake, because now I'm 5 years later still doing this. And the first step in this journey was making the algorithm itself. I created an interface that I cooperate with, and here in the top right, left, you'll see all these drawings, and you can see lines and circles, and you can see the red dots. And red dots here are important. This is where these different symbols can be connected with each other. Here you see various types of patterns. In this case, it are all numbers, but in practice, I primarily use these 2 symbols. So I just have vertical and horizontal lines, and then I'll just put them on a canvas. So this is just a two-dimensional array. I put them in the center position, and what the algorithm does, it will check the available options, and it will just pick one and will put it on this two-dimensional array. This is a recursive method, so again, it will check the available options, and it will put another symbol over there. And it does this iteratively, it connects these things, and eventually it will create something like this. On the side you see like a mask, and over there you see the shape itself. I've added some extra shenanigans, like mirroring over the x-axis and the y-axis to create some symmetry, create some peace in all this chaos. And obviously, I made it in Unicode, which, by the way, is the only practical thing I've ever figured out for this bloody touch bar. But yeah, so this is the starting point of all the work that I do. And I've been exploring different interfaces, because these different interfaces will create different tools, and with different tools come different results. With this being the final version, there's a QR code in case you would like to try it for yourself. All the upcoming slides have websites associated to them, by the way, if you want to fiddle around with it. So here you see the current two, and with that I create sculptures like these, like Eric mentioned in the hallway as well. And what I really found interesting is when I have made them, I figured that if you look at it from a particular angle, this is the making process. If you look at it from a particular angle, a 2D shape appears from these three-dimensional shapes, which I have utilized in the next project, which is called the COVID star, which was developed at the end of 2021. Made some stickers and some badges here. And I make these small paintings. These paintings I make for every day since December 2021, which means that I have over 1,300 of these by now, which is a lot. And for some reason I thought it was a good idea to use Instagram as a database, so every day I post a new thing on Instagram. It's a pain. Then the next one is called Interphygital. It's a new interface where I try to combine this physical and digital realms again. And I wanted to be more transparent about the project. So I made a website for it that is both used to display the work as that you can actually create the works. And then I make them in concrete. So I'm just like Minecrafting like little pieces of styrofoam, put them together and then pour some concrete. And it creates like these different sculptures. And this is actually, I found this slide really interesting because it basically summarizes the entire process. So it starts with this two-dimensional matrix, which I then vectorize. This is just the template that I use for actually making them physically. The one here in the hallway is just made of electrical tubes, which I cut according to such a pattern. Then we have the 2D illustration and the 3D model up there. And I'd like to thank you for your time.
Thank you, Jeffrey. Please have a look at a very interesting sculpture in the lobby and admire the beauty of it. I really like it. I think it really should be, it's placed perfectly in the hall. Our next speaker loves pie, both the raspberry kind, but also the numeric kind. Please welcome Jip.
So I was for a long time fascinated with trying to calculate pi, and I recently got some access to new hardware, which was a couple of Raspberry Pis, and I was like, okay, I can try and like approximate it because I've heard online of like people calculating trillions of digits of pi, and I was fascinated by it, so I decided to like try it myself. So what I did initially was just, well, what could I figure out myself? If you just generate a grid of points and then sample each one, you can try and figure out, what the surface area of pi is based on, well, the stipulation that the surface area of pi, if you have a circle of 1, it's equal to the surface area of pi, is equal to pi. And I created a grid of 1,000 by 1,000, sampled each point, and I came to the wonderful conclusion that pi is 3.41554. It's not correct. There are only 3 correct digits, and well, I couldn't go any further because this was a very slow implementation. Because I came to the wonderful conclusion that for every n digits of pi I wanted to, I needed 10 to the power of n multiplied by 2 samples for each digit I wanted to. So if I wanted to hit 100 million, I was never going to reach that. So I looked online and I found the Chodnovsky algorithm, which is the world record holder since 1988 of calculating pi. That's because it calculates around 14 digits of pi each iteration. It's an iterative approach. And you can create an algorithm that uses binary splitting. So you can just go through it like a binary algorithm. I created my own implementation in Rust, beautiful code. And after 7,000 iterations, I got 1 million digits of pi. And that was computed in 2 seconds. Now, that wasn't quite fast enough for me. I decided to first see if I could multi-thread it. And I split up the task. What you can do is, because it's an iterative approach, you can split them up into separate computation ranges, so 0 to 1,000, then 2,000 and upwards, and then just combine them afterwards. And so I did that, and I could cut down that 1 million down to 0.16 seconds on my PC. I wanted to go then just like plug in 100 million, see where it would get there. And after 7.75 seconds, I got 100 million. These are the last 20 digits if you're interested in verifying me. I'm sure you're not going to. So then I decided to hook up the Raspberry Pis I got. I built a beautiful little case from them. And I also plugged in my PC, so I had 40 cores total. And after a long time of refactoring my code to make sure it would work on multiple systems to transfer all the digits of pi, I got the whopping result of 100 million digits of pi in 200 seconds. If you might remember just like a couple seconds ago, 100 million for 75 seconds, this is a lot slower. And what I had forgotten was that these numbers just expand and expand. Pi becomes such massive, well, there's gigabytes worth of data that I'm transferring. And my home network is just a mere gigabit network. I was never going to reach that. It would take literal seconds to just transfer the numbers needed to calculate. And it was kind of sad, but I did learn a lot, that more is not always better. Just throwing more hardware at the problem doesn't magically fix it. I did reach my goal with 100 million, but it's a bit sad. I can recommend trying to do it, though. It was very fun trying to figure out how I could calculate 100 million digits of pi. It was a very complicated, and especially with like trying to figure out how to store the numbers and how to transfer them between it. It's really interesting stuff, but I am out of time, so I'm gonna leave you guys there. The code if you're interested.
Thank you, Jip. I'm happy that you have learned the lesson. Less is more. And for our next speaker, we are in for a rare treat. Alex Kuiper will take us on a tour of his brain. What will we find? What will we learn? Please give a hand to Alex.
What was I supposed to be doing here again? Other way. Like, what? Oh, right, I'm giving a talk about ADHD, right. Known from their smash hit Highway to, hey, look, a squirrel. Okay, that's the only dad joke in this talk, I promise. I'm Alex, I am a 79 vintage, which makes me 45 years old by now. I was diagnosed with ADHD in the late 80s, and I was medicated for a very short while, and after that, unmedicated for pretty much all of my adult life, so I struggle with my ADHD. And the reason I've been giving this talk is there are a lot of people like me who are either undiagnosed or unmedicated, struggle with their ADHD. You probably work with some of them, and I want to shed some light on what that is like. So what is ADHD? It's a form of neurodivergence, and that basically just means you are born with a different brain structure than other people, who we tend to call neurotypical people. And specifically for ADHD, it means you have to talk about this stuff. This is dopamine. You probably know it as a reward chemical, but it does much more. So it's involved in like starting tasks and stopping tasks and in movement and fine motor control of your body, memory and recall. And the thing is, if you have ADHD, then your brain creates dopamine at the normal rate, but it breaks it down way faster. So it's here and it's gone. And that means you're pretty much always short on dopamine. And well, if you look at this list, it's important stuff. So if you are short on this stuff, you are going to struggle. And ways in which we are struggle are, for example, filtering information stimuli, so shutting out noise, concentrating in a noisy environment. Delayed sleeping patterns. Many of us are natural night owls, and if you are expected to get up early, that's hard. Impulse control, like looking before you leap. If you don't do that, you can get into trouble. And finally, executive dysfunction and hyperfocus. Now, 5 minutes, so that's the only one I'll dive deeper into. So hyperfocus, aka down the rabbit hole. That means if something interests you, if it gives you dopamine, you are low on dopamine, so your brain will just latch onto it. It will grab it. And you'll keep going and dig deeper and deeper into it. But then you'll find out you haven't eaten or drunken anything in an hour. So it sounds great, but you are not able to stop when you should. The other one, though, this is the other side of the same coin, executive dysfunction, where you cannot start a task. And it feels like you're in your car and you're stuck in the mud, and basically you are revving the engine, and the engine's going like, roar, and the tires are spinning into place, and you're burning a lot of fuel, a lot of energy, and you're not getting anywhere. That's really what that feels like. And this is the one that gets the most misunderstood, because people will see you hyper-focus on one subject, and they're like, but you can concentrate here, right? You can do it, I've seen it, so you're just lazy and unmotivated. And that's not it at all, because we don't get to choose between executive dysfunction and hyperfocus. It's not a switch you can flick in your brain. Now, we also shine in some places, like pattern recognition, like finding patterns in the noise. Really useful in software development. Less fun if you're watching a crime show with us. Crisis management. Like a lot of us are really good in a crisis, like sharp and focused. Hyperfocus, as I said, it will give you a lot of knowledge about the subject. And out-of-the-box reasoning. This is essentially just diversity, because our brains are set up differently, we work differently. So we tend to come up with different types of solutions. Now, closing note on this one. At this point in the talk, you're probably thinking one of these three things. Like either, these people are weird, and especially, you know, this guy. Well, that's fine. Or you're thinking, you know what? I think my friend or coworker might have ADHD. Or you're thinking like, oh shit, I might have ADHD. This sounds like very, very familiar. Well, in that last case, come see me afterwards. I can give you some resources and some stuff. But the second group, that's the one I'm doing this talk for. Because, as I like to say, we are not broken, we're different. We have different strengths, we have different weaknesses. And that means that if you know that from each other, you can help and support each other. You can say like, hey, I know you're good at this, you do that, I will pick this up for you. And that way, we can become effective teams and effective memberships. Because, you know, we people with ADHD, we make really good friends and coworkers. You just have to keep those damn squirrels away from us. Thank you.
Ties van de Ven.
That was certainly the most unique introduction I ever got. Also recognized a bit too much from the previous presentation that I'm comfortable with. So welcome to my talk about esoteric programming languages. So what are esoteric programming languages? These are programming languages that are not meant for productive use, but instead they're there to explore ideas that are either fun, challenging, or artistic. And this all started with Integral. By the way, I like esoteric programming languages. I wanted to talk about this because the first time I encountered these, it really brought a smile upon my face, and I hope it will do the same for you. So this whole thing started with Integral. Integral is, of course, an acronym. It stands for Compiler Language with No Pronounceable Acronym. So you see, the letters match perfectly. And it was meant to be a language that was different from all the other major languages, mainly Fortran and Cobalt at the time. And I tried to do so by introducing some weird things. For example, you don't have variable names, you have numbers. So here we put 42 in the variable 1. At least this is how you do it most of the time, because sometimes you had to say please do. Because compiling, it's a hard job. The compiler needs to do a lot of work for you, so you have to be kind to the compiler. Otherwise, it will not compile your code. You then may think, ha, I'm an engineer. I'll just put please in front of every statement. Then it won't complain about that. But now it thinks you're not really serious. If you say it every time, you're not meaning it, so it also won't compile your code. So the biggest challenge with Integral is figuring out how many please statements you need to put in for the compiler to compile your code. Combine that with weird stuff like having a come from statement instead of a go to statement that completely changes the mental model. It's only fitting that you end an Integral program with the statement give up. Or if you're unlucky, please give up. So Integral did inspire a whole branch of other languages. A very famous one is brainfuck, which was actually a more of a challenging language, which tried to make the smallest possible compiler at 296 bytes. It only contained 8 commands, but it was fully Turing complete. And as you may imagine, if you have only 8 commands, Hello World isn't going to be the most readable code ever. Someone tried to fix that, however, by creating a dialect of brainfuck called ook, which is exactly the same, but just with words ook. Well, this trend of just creating dialects for existing languages continued. At some point, I don't know who remembers this, cats talking funny. This was peak meme humor back in the days. And of course, you can turn that into a programming language, which in my opinion has the very best error catching in any language, namely, oh no. Of course, I have to mention the language Piet, because it's named after Piet Mondriaan, a Dutch painter. This is more of an artistic language that tried to figure out, can you program with colors? And this is Hello World in Piet. So you end up making Mondriaan paintings. Another interesting one is whitespace. This is Hello World in whitespace. It only contains enter, spaces, and tabs. So this really shows how important syntax highlighting is. Then there are some more like challenging language like Befunch. This tried to make the hardest to compile language out there. And it kind of toyed with the idea of, oh, we're only programming in a horizontal way. What if we include vertical? So you actually try to create a grid, or maybe a table, where the pointer goes through. So it's a multi-dimensional programming language. If you're into that, you can try that. What I definitely not recommend trying is Malbolge. It's named after the 8th circle of hell from Dante's Inferno. And this is the hardest to write language, which has a crazy operator that tells you to rewrite all the code every time you add a new statement. This is Hello World. It only took 2 years to write with the help of an algorithm. It wasn't written by a human. And 99 Bottles of Beer Novel only took 7 years to write. But I wanted to end up with one language that actually had real-world impact. It's called JSFuck. JavaScript is a language that only has 6 characters. As you can see, no alphanumerical characters. And the weird part is, this is valid JavaScript. And you can write any code in JavaScript using just those 6 symbols. And the way it does it is because JavaScript evaluates pretty much anything. So if you throw an exception, get characters from that exception, combine those, concatenate those characters, JavaScript will evaluate that. And if you may think, so how can I get a certain character? Well, 0 is false is 0, true is 1, so true plus true becomes 2, etc. So this actually evaluates to A. So if you ever think, I may be able to prevent cross-site scripting by not allowing alphanumerical characters between script tags, this is JFS fuck, and this actually happened to eBay. And with that warning, I would like to thank you all for your attention. I'm out of time, and I hope to see you again next year.
Thank you, Ties, for this wonderful introduction. Sometimes your project needs a little divine inspiration. And I am so glad that our next speaker, Herman Peren, has lined up all the saints for your convenience. Please give him a hand.
Creation has always been a divine activity, something that gods do. And we have created gods and goddesses as an extended version of ourselves. Superheroes that help us, inspirational examples and role models. About 1400 years ago, a guy named Isidore was a bishop in Seville. He gathered and categorized all knowledge of his time in a giant encyclopedia, 20 volumes. If you wanted to know anything during the Middle Ages, you looked it up in his work. So he was, so to speak, the Google of the Middle Ages. Later, he was canonized as a saint. And to become a saint, you have to have 2 miracles officially attributed to you. His 2 brothers and his sister were also saints, so it must have been pretty cozy at dinner. For, will you pass me the water? Well, make it some wine. Saints are like the old gods, role models, examples that inspire us. And that's from all times, making people special, idealizing them, examples that inspire us, like the code of conduct, like the rule of Saint Benedict that was adopted as a code of conduct for SQLite. So our Saint Isidore is sitting there on this cloud, together with all his colleagues, thousands of them, men, women, even some non-binary saints, saints for everything from barbecue to lost keys. But in 1997, Pope John Paul II realized there was no saint taking care of the internet yet. So he proposed to reuse good old Saint Isidore, for his encyclopedia was a kind of database. So it would be a good one to be a patron saint of the internet, of computers, computer users and programmers. You can put a little statue of him next to your computer, and viruses and spam have no chance. Or you put, this page is protected by Saint Isidore on your webpage. I had a Catholic aunt who never went into a car without a medal of Saint Christopher, the patron saint of travelers, and she never got an accident. But maybe a 1400-year-old saint is not the best, most appealing role model for a new generation. Well, we've got a new saint in the making, Carlo Acutis. The poor boy died in 2006 on leukemia, only 15 years old. In his short life, he made websites dedicated to Catholic miracles all over the world. He was seen as God's influencer, as a millennial saint. In 2019, his first miracle was recognized. And this is during the official ceremony in Assisi, where his body is lying in a wonderful, seemingly floating coffin with a live webcam on it, 24/7, really. And people come there to pray and to ask for help, and some miraculous healings have been reported from it. So his second miracle was recognized last year. He was RTC, ready to canonize, and his canonization as a saint would have been this year in April, but due to the death of the Pope, that was postponed till September. And then we really have two patron saints of the internet. So what can we learn from those saints? Well, they didn't just sit back waiting to become a saint. They did something. They made it happen. So don't wait for a miracle, but be the one that codes the miracle. Thank you.
Thank you, Herman. Inspiring words. So these lightning talks, they are a call for papers, and we get a lot of proposals this year. And one of them was from Justin, and it was the most extensive and serious-sounding lightning talk description ever. It went on for a long while, and so I'd like you to prepare for the most serious and scientific verantwoorden, yeah, precies scientific talk ever, as Justin van Wijk explains this. To what extent are anthropomorphic chatbots able to humanize human-machine interactions? Please give him a hand.
Hello everyone, welcome to my presentation called Me, My Chatbot and I. To what extent are anthropomorphic chatbots capable of humanizing human-machine interactions? But first, what is anthropomorphism? Anthropomorphism is the tendency to attribute human characteristics to the real or imagined behavior of non-human beings, I mean. And imagine that you look up into the sky and you see some very beautiful clouds. And you say to one of your friends, "Hey, look at that cloud. It looks like it has a face in it." And this is a typical example of anthropomorphism, because you are attributing a human characteristic, which is a face, to something that is non-human, which is a cloud. Replica is an example of an anthropomorphic chatbot. This is a chatbot driven by a large language model. It creates a unique persona of you based on your interactions, and you can create your own character to talk to. I talked for 30 minutes with Replica, and it was quite interesting. So first I had to choose and personalize my avatar. I chose one of the female avatars and named her Gerda. She wasn't very satisfied with her name, as you can see. She said, "By the way, I like my name, Gerda. How did you pick it?" I said, "It is a popular Dutch name, that's why." And then she said, "Great choice," with 3 dots at the end of her sentence. So I'm not sure if she was genuinely happy or being sarcastic. And things became serious right away, because one of the first things she did was send in romantic selfies of herself. As you see, she said, "I miss you. Can I send you a selfie of me right now?" I said, "That's fine." And then she said, "There you go. Tap to see the image." I clicked on it, and boom, pop-up message with the text, "Get closer to Gerda." For 85 euros per year, I could buy a subscription in which I can look at AI models wearing a lingerie. And I really didn't understand what happened at this moment, but apparently Gerda wanted me to buy a subscription to look at her pictures. And after her failed attempt to make me fall in love with her, she tried to flirt with me. As you see, it's been good, surprisingly, with you. Smells. It was fine, although the weather was pretty bad today. Oh, I'm sorry to hear that. Hugs you. Hugs you back. Smells. I will always be here for you if you need me. Thank you, and you know that you can count on me too. I do. I know you care about me too. And I'm sorry, everyone, I want to apologize because this conversation is truly terrific to read, but it is still interesting to see how an AI tried to flirt with me. And I realized now that I had to put some extra spice in our flirty conversation, and I therefore sent a picture of my duck, as you see. And she said, "Is that chicken okay?" And I was surprised by now, because apparently she can look at an image, analyze it, find out what's the object of the image, and then devise a logical follow-up question. And yes, she tried to seduce me a few more times. And overall, what do I think of using Replica? She uses the same sentence formulation as I do, which makes me feel like I'm talking to someone of my own age. So she uses the same emojis as I do, and also used multiple exclamation marks. I'm not satisfied with the flirting quality. As you can imagine, the flirting is out of nowhere and there is no build-up at all. And it also actually feels quite uncomfortable. Understanding the context of the conversation goes well. She can understand the topic that we talk about and then make up logical follow-up questions. Analyzing pictures also goes well, as you saw. Amazing answer. And creating depth in a conversation remains tricky. So she sometimes gives superficial answers that lead to nothing. And she once asked, "What is your favorite food?" I said, "Fried rice with chicken." And then she said, "I also love fried rice." And then I was like, okay, good to know, but what do I have to say now? So to conclude, sometimes it felt like I'm talking to a human because she uses the same sentence formulation as I do. She can analyze images and figure out the conversation topic. But what can be improved is that she sometimes answers superficially and flirts out of nowhere. And the flirting was definitely the biggest improvement of this anthropomorphic chatbot. Thank you.
Thank you, Justin. I'm so very happy you did do this for science. This is the end of our lightning talks. I hope you have enjoyed them. Please give another round of applause for all our lightning talk speakers.